In this video, we will be discussing about equilibrium. In order to understand the concept of equilibrium before seeing it in a chemical reaction, let's try to understand what the concept is all about. So, in front of you, you can see two images. One wherein water is falling into a container and moving out of it. That's what you see here. That's what you see here. And another one where a person is doing exercise on a treadmill. So let's first discuss about this situation and then we will see what's happening here. In this particular situation, what is happening is you can see water is falling into the container, but at the same time water is flowing out as well. Whatever is the volume of water that falls into the container, same quantity or equal quantity of water is flowing out as well. So even after several hours of time, even as the time pass by, you will not be able to see that the water level goes up. At the end of the day, even at the end of the day, the water level will remain where it is. What is the reason? Of course, water is flowing in, same quantity of water is flowing out, meaning two actions are happening but in opposite directions. One which is trying to fill the container, another one which is draining water out of the container. So that's the concept of equilibrium. Two actions will be happening, but they will be in opposite directions. They will be opposing each other so that the resultant, the output will be zero. Now let's see this situation. Here you can see the man is walking on a treadmill. Even if he walks on the treadmill for the whole day, you are not going to see any visible change in the position, in his position. The basic reason is because the belt here is moving in the backward direction, but the man is moving in the forward direction. Both the actions oppose each other, and that's the reason why even if he does exercise for the whole day, the position of the man doesn't change. He will be remaining where he is. Here also, like before, two actions are happening, but they oppose each other so that there is no output, there is no visible output. Now let's try to apply this concept in. So here, this test tube is having a colorless gas. It is nothing but, this is N2O4, that is colorless, and here we are having NO2, which is a reddish brown gas. So now let's try to understand the concept of equilibrium with this particular reaction. Here Here N2O4 is present in this test tube, which is colorless, and as time passes by, this N2O4 breaks down to produce NO2. So gradually, as the NO2 amount increases, you will be able to see that the reddish brown color gets more and more intensified. But after a point of time, you find that the color intensity is remaining constant, it is not changing. That's because at this particular stage, this reaction has reached the state of equilibrium. Here, what is happening is N2O4, I'll write down the equation so that you can easily understand it. Yeah, here N2O4 is getting broken down to NO2, that's the forward reaction, but proportionate quantity of NO2 is recombining to form N2O4. Equal or proportionate quantities of product formation and reaction formation is happening. Both actions are happening simultaneously in proportionate quantities, and that's the reason why there is no visible or noticeable change in the color intensity. This is the state of equilibrium. Two reactions will be happening in opposite directions, in the forward and the backward directions. Reactants will be formed at the same time, products will be getting converted back to the reactants. That's the state of equilibrium. That's all for this. That's all for now in this video. Let's see further in the next video. Thank you.